Hello everyone, welcome to our new lecture. We are learning chapter number 5, that is acids, bases and salt. In the previous lecture we have studied the concept of pH values and we have gone through the concept of universal indicator, which is used to identify the pH values of a given solution. Now in this particular lecture we are going to study about the reactions of acids and bases. So we'll start with the very first concept, that is neutralization reaction. For this particular concept, we are going to perform a certain experiment which is mentioned over here. Okay, so we will be taking 10 ml of dilute HCl in a beaker. Okay, then we will use a glass rod to put a drop of this solution on a pH paper. pH indicator strip and record the pH of the solution. Definitely the pH value of dilute HCl, okay, that is hydrochloric acid, will be less than 7, okay, as it is the acidic solution. Now again we are going to add few drops of dilute NaOH solution by means of a dropper and stir the solution with the glass rod. Okay. Then in the beaker we will put the drops of dilute NaOH and we will stir the solution. Measure the pH of the resulting solution by putting a drop of this solution on other pH paper, and in this manner go on adding dilute NaOH drop by drop and recording the pH. Okay, we will do this again and again. We will drop NaOH solution in the beaker and then again we will measure the pH value and so on. Stop adding NaOH when a green color appears on the pH paper. That is when the pH of the solution becomes 7. Okay, we will do this till the pH value is 7 for the solution. Okay, now this particular experiment clarifies the concept of neutralization. Okay, let us see what is neutralization reaction. So a question may arise that why does the pH increase as a NaOH solution is added drop by drop to the HCl solution? The answer lies in the process of dissociation. We know whenever we are going to add the HCl and NaOH, okay, in their aqueous solutions, we will be observing that the elements of this compound are going to be dissociated. Now addition of NaOH solution to HCl solution is like adding a large concentration of OH minus ions to a large concentration of H plus ions. Okay, so when you add NaOH with HCl, you are definitely adding OH minus ion, okay, with H plus ion. However, water dissociates into H plus and OH minus ions into a very small extent. You will observe that whenever you want to dissociate water, the dissociation is not going to be 100%. The H plus and OH minus ions in the water dissociate very less, okay, in a very small amount. Therefore, on mixing the excess OH minus ions in combined with the excess H plus ions to form H2O. So when the number of H plus ion and OH minus ion in the solution is more, at that time you will see both these ions are going to combine together and we will get the molecules of H2O, that is water. Okay, and we all know that the pH value of water is 7. So when we get the pH value of water 7, that means the complete dissociation of the HCl and NaOH has taken place and more number of H plus ions and OH minus has been dissociated, which are combined again to form H2O. Okay, therefore on mixing the excess OH minus ions combined with excess H plus ions to form H2O molecules which mix with the solvent water. These changes can be represented by the ionic equation shown as follows. So you can see in HCl, H plus and Cl minus, okay, dissociation of these elements has taken place. Then we see the dissociation of Na plus and OH minus ions. Okay, then we get Na plus Cl minus and H2O is formed, that is water molecule has been formed. It can be seen from the above equation that the Na plus and Cl minus ions are on both the sides. Therefore, the net ionic reaction is H plus OH minus ion, that is H2O. As the NaOH solution is added drop by drop to the HCl solution, the concentration of H plus goes on decreasing due to combination with added OH minus ions, and that is how the pH goes on increasing. So as the number of H plus goes on decreasing, okay, due to adding the OH minus ions, so when the when the value of H plus decreases, pH value increases. Okay. When enough NaOH is added to HCl, the resulting aqueous solution contains only Na plus and Cl minus ions, that is NaCl. Okay, and what is NaCl? It is a salt and the solvent water, which is formed due to the combination of H plus and OH minus ions. The only source of H plus and OH minus ions in this solution is dissociation of water. Therefore, this reaction is called the neutralization reaction. So what we call this reaction as neutralization reaction. So the neutralization reaction is also represented by the following simple equation. And what is the equation? That acid plus base gives us salt plus water. So when you add hydrochloric acid with NaOH solution, that is sodium hydroxide, you will get common salt, that is sodium chloride, NaCl, and you will get the molecules of water. And this molecule of water is responsible for the neutralization of the given compounds. Okay, so that means the H2O neutralizes the given compound. Okay, hence it is called as neutralization reaction. So here certain reactions are given to us, okay, which can be used to study the neutralization reaction. So we have HNO3, that is nitric acid, as our acid, okay, and definitely we want a base over here which will give us potassium nitrate, KNO3, and H2O. So we are going to take here the base, which is KOH. Okay, KOH, that is potassium hydroxide. It is potassium hydroxide. Okay, so the reaction between nitric acid and potassium hydroxide will give us potassium nitrate and H2O, that is water. And again we have here two molecules of NH4OH which must be added with a certain acid and which will give us NH4 twice SO4, that is ammonium sulfate, and water. So here we will have the acid which is H2SO4. Okay, H2SO4, that is sulfuric acid. We will have here sulfuric acid. Okay, then here we have potassium bromide as a salt. Definitely we want your water molecule. We have your KOH, okay, and as an acid we will have HBr, okay, that is boric acid, HBr, hydrogen bromide. Okay, so this is the reaction. Okay, examples for the neutralization reaction. Okay, here we will have water, H2O, okay, KBr plus H2O. Here also we will have H2O. Okay, so this is the concept of neutralization reaction which we have studied today. Now we will study about the reaction of acid with metals, okay, and reaction of acid with oxides of metal in the next lecture. Until then, goodbye. For this lecture you will have homework. You have to complete this table in your notebook. Okay, so we will meet in the next lecture. Until then, goodbye.